Hi, my name is Sven and I want to show you in a short way how to use our FFT tool for MATLAB. First of all, be sure that the whole program folder is inside your MATLAB path to avoid any errors. To analyze data, you have to put all your files with the sinusoidal data into one folder. The data can look like this. So I have two columns with ASCII formatted data in 15,000 rows. This is good data for our analysis. So if you have this, you can choose the folder with your data with this button, and after it you have to choose a results directory where all the files with the results of the analysis will be saved. So you can browse any folder on your computer, or by pressing the plus button you can create a folder named with the current date and time inside the parent directory of your data folder. So if you have done this, you have to choose one of the columns of your data. So I've shown to you my data has two columns and I want to analyze column 1. After it you have to say the program how many files you want to analyze. So you can press plus or just the minus button, then the program will count the number of files inside your data directory and set it to this edit. Then you have to do some settings here. The sampling rate is the rate of your data, and the rest I will explain to you later. Rows, I said my data has 15,000 rows. The program will analyze this by itself, but if you want to decrease the value, you can do it as ever you want. Before we can start, we just have to do two more settings. This one I will explain to you later, and the window function describes the way the program will try to find the lowest noise. So Henning, Drake and Blackman are normal window functions, and cutoff I will explain to you later. So before we can start, I want to show you the menu bar. You have file and some options and some language options and the about button and two more tools which you can get with the button edit. So you can prepare the data. That means that you exchange all the comma by dots in your data if you have it. And average means if your sampling rate was too high, you can do an average calculation over an amount of your choice of data points to reduce the amount of data, which average or average all. You can try it by yourself. Okay, so now we can start. Then you see the fast Fourier transformation of your source data, the first file. So this is the stimulating frequency of your source data. You have to put the data here inside the program. So in my case it's 10 Hz. And AHH means amount of higher harmonics, and that describes the limit of the x-axis in the FFT spectra. So I want to display 5 higher harmonics, so 1, 2, 3, 4, 5, and the last one is to enlarge the range. So what we have to do now for the analysis is to click on the frequency we want to analyze. In our case it should be 20 Hz. So you can see the program puts a fit, the black line in this plot, under our FFT spectra and saves the data of this fit. You can save the whole fitting curve in separate files if you want that, and then you can see how this fit will develop over all your files in the data folder. This interruption time is here to give you the chance to control the fitting tool, so you can see if the program doesn't get the right fit. Later it will fit very sure, so you can reduce the number the seconds to 0 to make it much faster. So if the progress is at 100%, you have the chance to have a look at the determination of several parameters of this fitting curve. So the peak intensity means the height of this point. Peak position is just 20 Hz. The peak width, this is a Gaussian curve, so the width is the sigma, 2 times sigma, and the peak noise is the value of the black line. Yeah, so that's it. All the results are saved in this folder. You can see them here. And now I want to show you some other ways to do that. I will restart the program to avoid errors. Okay, so you have in addition the possibility to analyze more than one frequency at one time. So I will, the rest stays the same. Now you can click at 20, 30 and 40 Hz. The red area is the area in which the program tries to find the highest point to get the location of your search frequency. Okay, now you can see in this subplot area all the fits of the 3 frequencies. Okay, I forgot to increase the number of files, so nothing will happen now. No problem. You have seen what I wanted to show you. Instead of window functions, you could use the cutoff method to find the minimum noise. This method tries to find a complete sinusoidal oscillation by cutting off several data points and calculating after cutting one data point the new FFT, and of each of all these several FFTs the program tries to find the minimum noise. Cutoff is the number of data points cut off over time, so the larger this number, the longer this procedure will take. Beside the fitting curve under your graph, you could use the max function to just find the maximum point in your FFT spectra. I want to show it to you. With the cutoff method, you need to mark an area where the program tries to find the minimum noise. So I want to take this area. After it, you had to click on the search frequency as in the window functions. Then you see the program calculating, and you will get maybe different result than with the window function. You have to try it out, which one is better for your aims. Thanks for watching.